Like a rare item? Yeah, I'm live. I should be live. Let me know if I'm live. Just got invited to have dinner. We're live. Right on. Then let us begin. Hey everyone, welcome to this October 28th edition of Open Space. I'm Fraser Kane, publisher of Universe Today. I have no idea what we're going to talk about today. That's your job. My job is to just blather straight for an hour. Your job is to ask interesting questions, to shape this conversation in directions that none of us had any plans that it would go to. I learned from last week's terrible mistake. I have a glass of water here. Check it out. A glass that has my face on it. Whoa. From the Astronomy Cast 500th episode celebration. All right. Let me think if there's any other interesting news to do. Let's see. So we are working on an episode all about Venus rovers. So there's a bunch of really interesting ideas for roving the surface of Venus. And a lot of this comes from new technology that NASA has come up with. They developed silicon carbide electronics, which were developed for fuel sensors to be put inside jet engines. And it turns out that these can handle being on the surface of Venus. The temperatures, the pressures, not necessarily the corrosion levels, but if you can protect them, it's theoretically possible. So there's a bunch of new rover ideas that are based on that. But there's also an idea about just like a completely clockwork rover where it just uses wind to push all its mechanisms and even to communicate with space, which is kind of a bizarre idea. But you're going to have to wait for the episode. That's going to probably come tomorrow, I think, if our schedules work properly. The next episode that I just finished writing, and it's in the can, so now Chad's going to, I guess that's not what that means. I've finished writing it, and then Chad is going to start editing it, but that'll come after the Venus episode. And that's all about the idea of galactic panspermia. So where we already know about the idea of just panspermia, but the question is, could you get objects from star system to star system? And the problem is that, well, say if you want to get rocks off of the surface of Mars, you only have to go about 5 kilometers per second to hit escape velocity from Mars. But to actually leave the solar system, you have to go about 40 plus 50 kilometers per second if you're like starting at the Earth's orbit, which is like where the life would begin. So their idea is that you send comets, and the comets fly through the atmosphere, and comets are already on an orbit where almost nothing will push them out of the solar system entirely because they're on these really big, long orbits. And so they come through the solar system. They, Strand Beast on Venus. They pass through the Earth like maybe 100 kilometers up, scoop up a bunch of material, and then head back out into the outer solar system. And then they interact with something else, and then they get shoved out into deep space. And they figure that it's probably happened 100,000 times in Earth's history that a comet has grazed the atmosphere and gone off into space. So it's a great idea. I really like it. So anyway, those are the next 2 episodes. And then I think after that, I'm starting to work on sort of the monster James Webb episode, because, I mean, last week it was nothing but questions about James Webb, or half questions about James Webb. So I think we'll be talking about that. But then also we're going to get probably Paul Geithner to come back. He's someone from Northrop Grumman who has worked on James Webb, and we'll talk to him about the nature of James Webb and just answer all your questions about James Webb. So stay tuned on that. And this is going to be, I think, my 3rd solo episode. And so now I think we're going to try to go back to getting some guests. So, all right, well, let's get into your questions. So start punching them in. Of course, if you can put the question mark in front, then that really helps me notice that it's a question. If you don't know how to make a question, then just put 5 or 6 question marks in the beginning, and that will help notice. But there's a little question mark icon that if you can find that, then that's awesome. So that really helps. Big thank you to the mods and the people who are working to transfer the questions from the chat to another place where I can see them, and that makes it really easy, so I can actually pick them out and try to catch questions that have come back around. All right, so Zapfan asks, has Canada gotten an exoplanet to name? I don't think there are any rules for naming exoplanets yet. I think the IAU is starting to take in ideas for naming planets, but I don't know of any specifically that have come. Now I would assume that there will or have already been some names, often like some cool kind of First Nations names. First Nations is what we call Aboriginal peoples in Canada. So, you know, I'm sure there's going to be some interesting names will come from First Nations mythology here in Canada. That'd be really cool. Draga, thoughts on Hygiea? I don't know the name. Can you give me some context? I haven't even heard of that. An object in the asteroid belt? I don't know, did something... Oh, here we go. The impact simulation explaining the origin of its round shape. Oh, neat. Okay. I guess it's just the smallest dwarf planet. Okay, this just broke. I've been too busy working on other stuff today, so I will get myself up. I'm sure I'll be up to speed by tomorrow, and so we'll have to talk about that next week. That's really cool. Grisha asks, if I could send a lander rover to any place in the solar system, where would I send it? There's a bunch of places I'd like to go. I would like to see, probably Iapetus is one place that I'm really fascinated with. I mean, obviously I'd love to see the surface of Europa, but Iapetus is this really interesting object where half of it is coal black and the other half is pure white, and how did it get that way? I mean, they think that it gobbled up a moon, or a ring, but it'd be interesting to sort of see what that looks like down on the surface, how it's sort of pelted by snow material or pelted by darker organic material. But this, I mean, there's too many places. I would love to see, I mean, we saw those pictures of Pluto, but I would love to see what that looks like up close. So, I mean, how can I even answer that, right? Samuel Baker, has NASA done any sex studies in space? No, not that I'm aware of. So we have no idea. Oh, that was weird. All right. Saraneth says, how can black holes merge when, from our point of view, nothing ever crosses the event horizon? That is a great question. And that is sort of that's one of the reasons why the black hole information paradox is a problem, right? Is that from an outside observer, as some object approaches the event horizon of a black hole, time dilation makes it so that for it experiences much slower time than we experience, or much slower time than we experience out here in the rest of the universe. And that was what happened in the movie Interstellar. And so from our perspective, as some object falls into a black hole, it just appears to just pause on the surface of the black hole and then just redshift fade away. So if that's what we see, how do they actually merge? Well, from the perspective of the black hole, right, it all just happens instantaneously. Yeah. You know, if you fall into a black hole, from your perspective, you fall into the black hole and get torn apart. It's just that the end of the universe may have happened. And then the weird part about that, right, is that then we know that black holes will evaporate in a finite amount of time. So how can a thing that is paused and from your perspective never get sucked in, yet somehow be part of the black hole and eventually evaporate out into space? And that is the heart of the black hole information paradox. And feel free to answer it. If you can, you'll get a Nobel Prize. David Morgan asks, maybe a stupid question, but in space, which is a vacuum when a rocket engine fires? What's it pushing against? If a vacuum, how does it move? Well, a rocket moves by throwing exhaust out the back of the rocket at high velocity. And it's the same thing, you sit on a chair, hold a really heavy object, like a bowling ball, throw a chair with wheels, throw the bowling ball one way and you will roll the other way. And it's not because the bowling ball is pushing against the air, it's because you are throwing the mass away from you and you experience an equal and opposite reaction. It is a balance of forces. And so as you throw the ball, you go the other way. And the same thing happens with a rocket. A rocket is throwing hot gases out of the back of the rocket, and the rocket itself receives a kick in the opposite direction and flies into space. And when it's out in space, same thing happens. So play some Kerbal Space Program. You'll totally be able to wrap your head around it. Unless you're using this as a justification for conspiracy theories that nobody goes to space, and then obviously there's no convincing you. Mucky H says, what do I think of metallic hydrogen? So if metallic hydrogen is thought to be at the center of the biggest planets like Jupiter, and essentially you've got so much pressure and temperature down at the core of Jupiter that hydrogen, which normally is just a nice fluffy gas, becomes incredibly dense, denser than rock, denser than metal. And it takes on some of the characteristics of metal. And so one of the things that's really fascinating about this is that in theory, if you could use this stuff, it would have the kind of densities, the kind of energy density that you would want to be able to have a single stage to orbit spacecraft. You could have a very, you wouldn't have to carry enormous amounts of fuel. You could fly around the solar system, and it would very much be like The Expanse with the Epstein drive. So, it's been thought that metallic hydrogen has finally been created in the lab, but obviously it was an incredibly difficult process to be able to do that, and probably more than just a couple of atoms of it. And then how do you hold it under that kind of intense pressure? I mean, you sort of have to hold your hydrogen in a vise and keep it clamped together to get that kind of pressure. But maybe that's something that people will be able to figure out. If they do, then it changes everything, right? Because then suddenly you've got this energy source that provides the kind of exit velocities that you need to be able to fly to space in a compact spacecraft where you just refuel yourself and fly around the solar system, as opposed to the situation that we're in now where rockets are 95% fuel and a tiny little bit payload. You could swap that around. It would be much more like a car or an airplane. So here's hoping. Donovan Gustafson, what is your most memorable space event that you've witnessed? I've done the trifecta, right? I've watched a rocket launch, which I watched the launch of OSIRIS-REx in Florida. That was amazing. I've seen like stunning auroras. I've seen the kinds of auroras where the sky just explodes in green and purple light. That was a couple of years ago, and that was incredible. One of the best experiences of my life. And then I've seen a solar eclipse, but I didn't get a chance to see all of totality. So I was there in 2017 for the one that crossed the United States, but we got clouded out for most of it, and I saw just the last seconds of totality. So I didn't see the good experience of a total solar eclipse. So I'm going to set that one aside and come back to it later. I live streamed the transit of Venus across the surface of the sun. I've seen many lunar eclipses. And I've seen one meteor storm, which was the Leonids in 2001, and that was incredible. It was like meteor every couple of seconds, just like zip, zip. And then I've seen a bright comet, Hyakutake, which was back in 1996. I also saw Hale-Bopp, but Hyakutake was better for me. So of all of those things, man, they're all incredible. The one that I think I want to experience again, obviously I want to get the proper solar eclipse where there's no clouds at all, but I want to see that Hyakutake again, right? I want to see a really bright comet, naked eye comet, pass close to the Earth so that we can see it. I mean, we deserve a really bright naked eye comet. So that's the one I think that I want, is the one that I want to see again. it was mind bending to watch it, and there hasn't been one in 20 years, 30 almost, right? Is that right? 20 years? Yeah, 20 plus years. That sucks. We deserve a bright comet. And I talk about it in this video that we'll be releasing about galactic panspermia, that just like, that's 15 million kilometers away. Imagine a comet scraping through the upper atmosphere. Like, can you just imagine what that would look like? Yeah, that'd be amazing. Let's see. Southern Scientist, have you seen any time travel videos on YouTube? If you search for Fraser Cain time travel Star Talk, Neil deGrasse Tyson answers my question about time travel. So check that out. Easy Tiger 10, could Valles Marineris have been caused by an asteroid scraping along the side of Mars? It's very straight, like a scratch in the car. No, the thinking for Valles Marineris is that you had Mars and you had all this volcanic uplift, and essentially the planet cracked open in another part to be able to support all of that volcanic uplift. So no, not a scrape. Anytime that you get an impact from space, like a crater or a meteorite strike or something like that, you get a mostly circular impact. No matter kind of what angle the object is coming in at, it forms a circular crater. And it's just because the way energy is transferred from an object in space to the ground, it just directly turns into a giant crater, which is why if you look, you can imagine there's all these angles that objects would have hit the moon at, and yet all of the craters are round. And that's just because of the way the transfer of kinetic energy works, is you get this sort of very circular shaped crater. So a big object wouldn't scrape along. There's a couple of objects, a couple of impact craters that are like that, but most of the time you get a circular crater and then all the ejecta blanket. Andrew Firm says, why does the Ariane rocket not have a launch abort system? Shouldn't we try to save all our hopes and dreams and $9 billion if things get too spicy in the beginning? Didn't you post that as a comment? Yeah, well, no cargo rockets have an abort system. I mean, none of them do. And that's because abort system takes up fuel and takes away from the payload. And James Webb is a monster, right? James Webb is I forget the exact tonnage on it, but it's 10 tons? Anyway, it's like the limit of the Ariane 5 rocket. They're going to do everything they can to get that thing into space. So it's crazy. And so none of them do. It's the only things that are going to have any kind of abort system are the things that are designed for human beings, right? The Crew Dragon will have an abort system. The Space Launch System will have an abort system. But when it comes to telescopes, not yet. Tim McConnell says, what would be the effect on the ground and atmosphere of a comet rays? What would we need to deflect? I mean, I think that you would get some kind of explosion in the upper atmosphere, but I don't even know if it's that high, if it's 70 kilometers high. The whole point of this is that the comet grazes through, doesn't really get slowed down very much, and then continues out into the solar system. So I don't think it would be that much. Moochie the Cat. Mercury is tidally locked, right? Dark side there? No, Mercury is not tidally locked. Mercury does rotate, but it rotates on a 3-2 resonance with Venus. But so no, Mercury is rotating. None of the planets are tidally locked to the sun yet. Sergio Botero, a question about missions to Mars. What are they going to do about the food? Carry tons of it and then get rid of the human waste in space? Well, in theory, they're going to try and reuse as much of the food waste, the poop, back into the system. So they're going to try to extract as much resources out of everything, out of the water, out of the human waste, and then turn that back into food. So just like the worms do here on Earth and the bacteria. So yeah, they're not going to get rid of it. That stuff is precious gold. Jesus Gomez, what do you think about ancient aliens in the History Channel? Do you believe anything about it? No, I don't believe anything about it. Citizen Case. Case? KC? Is it KC? Anyway, when considering the age of the universe based off redshift and cosmic microwave background, how have we considered the increase in the speed of the expansion since it is speeding up? So the increase in the expansion has been measured by detecting the supernovas, the type 1a supernovae that people, that are out there. And this was sort of this great discovery of dark energy back in 1998. And so, so it looks like for about the first 5 billion years of the universe's history, after the Big Bang, you would expect all of the collective matter to be pulling everything back together. And that's what happened. And then the weird thing is that about after the 5 billion year mark, the universe started to accelerate its expansion and is accelerating and accelerating now. And so that has been measured by figuring out the distance to all of these supernovae that are farther from us than you would expect them to be. Now, I don't know if that answers your question, so give me a sort of another version of it if you need to. Curious Borg, happy Halloween, Fraser. Do you have any ideas about astronomy-based costumes? What are the kids going to dress up as? Are you going to be dressed up for Halloween at all? No, I don't think so. I got nothing, but if people in the chat want to provide some ideas, definitely do it. Ellie Penoyer, what do you think about all the talk of Planet X or Nibiru being very close and in the sky we see being just a projection? I'm 70 years old and I believe the moon visit was real and interested in space. That's awesome. The part that you think the moon visit was real and that you're interested in space. So I have been debunking Nibiru and Planet X for about 20 years now. In other words, when I started this career in science journalism, 20 years ago, people were saying that there was a planet X and there was a giant planet Nibiru and it was going to pass the Earth, and it's not real. Like, they're literally just making this up. And why are they making it up? Maybe they're making it up to sell books. Maybe they're making it up to get people to watch their YouTube videos, to take donations. I don't know what the reason is, but it's not real. And there are people whose only job it is to look at the night sky with incredible telescopes all the time, and they don't see this. So some of the people they're seeing like a reflection on the inside of their camera. Other people just don't understand sort of the way the sky works. And some people are just making things up to scare people. So don't worry. There is no such thing as a Planet X, and there's no such thing as a Nibiru. And it's been around for 20 years. You can go back to my channel, and there's like an episode of like younger me 6 years ago saying it's not real. It's still not real. So, Third Rock Astronomy, isn't time, hey, on Twitch, right on. Isn't time only relative to the star we orbit? Yes. So every mass in the universe causes time dilation. The closer you are to that mass, the stronger the mass, the more time dilation that you experience. And so again, go back to that Interstellar movie that you're thinking of, and they were close to the supermassive black hole, and so they only experienced a day, and when they left the black hole, then the rest of the universe had experienced 40 years or whatever, right? And so here on Earth, we're experiencing a tiny little bit of time dilation, and other people in other places are experiencing different amounts of time dilation depending on how close you are to the star and how close you are to the gravity well of your planet. But the amounts are incredibly small. Like, you would measure it in terms of milliseconds, microseconds, in differences of time depending on your motion as well, right? But also the amount of mass that you're next to. Sort of the maximum amount, like if you're on one side of the universe and somebody else is on the other side of the universe, then you can have about 30,000 years of time dilation. So you would measure time differently, up to a maximum of about 30,000 years, thanks to the speed and expansion of the universe. And then if you're next to a really massive, supermassive black hole, then you might experience different amounts of time dilation as well. Donovan Gustafson, is it possible to brew beer in microgravity? I don't know. I can't see why you wouldn't. Yeast works in microgravity, but I wonder if there'd be some problem with like moving the gases away from the yeast, because there's no, a lot of making alcohol, you measure the specific gravity and there's no specific gravity. That's a great question. I guess we'll have to figure that one out. I'm gonna try to remember and see if I can get that answered. Corey asks, are there any good websites to help me calculate thrust required to move a 200-ton object at 0.3 g? Yeah, if you do a search for like a relativistic calculator, you can find some stuff that'll do those kinds of calculations for you. They'll tell you how much energy you need, what the starting velocity is, what the ending velocity is. You can go from there. Jim Smith, could we see Earth in the past by gravitational lensing of a black hole with a super powerful telescope? In theory, yes. Right? When you see a black hole, you get this crazy distortion of light, and that distortion that you're seeing is this part of the black hole where light is being wrapped around the black hole. It's called the photon sphere, and light is going in orbit or going around the black hole and coming right back at you. So in theory, you could, but practically, you couldn't, right? It's just too far away. Very few photons would be coming your way to be able to provide any kind of cohesive information about what you're seeing. Scott Collins, is there any consideration of building a long baseline interferometry gravitational wave telescope? I did an episode about the Lagrange points, and we did one on L2 and L3, and there's almost no use for L3, but one of the ideas is that you could use, L3 is the one that's on the other side of the sun, and so in theory, you could use you could use L4 and L5, which are ahead and behind the Earth in our orbit, and then use L3, which is on the other side of the sun. And you could have that form a great big triangle, and that could provide a very powerful gravitational wave observatory. And sort of the way things work, you can keep these things within about, say, 10,000 kilometers of their same, like the legs of this interferometer would be roughly the same distance and then would change by about 10,000 kilometers based on the movements of all of these objects. So you'd get a pretty accurate telescope for most of the time, which I think is a great idea. Cheesy McGeezy, do you want Planet 9 to be a primordial black hole? Sure, yeah, that would be awesome if it was a primordial black hole, but it's probably not. Anthony Thomas, if it were possible, could we put artillery cannons on the moon for defense against meteors, asteroids, using high explosives to bombard threats into smaller chunks? So one of the things that we're really learning about asteroids is that this idea of blowing them up with nuclear weapons might not provide any value. So when you look at some of the pictures of things like Bennu, which was taken by OSIRIS-REx, or Ryugu, which was taken by the Hayabusa 2 mission, they are just, literally, they are a pile of gravel, right? Just a pile of gravel that is mutually attracted by gravity into a shape. And so if you explode that with any kind of weapon, it's just going to go out, and then it's just going to come back together again, and it's gravel again. So trying to blow them up probably isn't going to provide any value. If we're going to try and move these asteroids away to make them to be safe, we're going to have to work in much longer time periods and use other methodologies that give us a shot at being able to shift them out of their orbit. BTT, would SpaceX be violating any international treaties by landing humans on Mars? Right now, the Outerspace Treaty, I've mentioned this in the past, right? The Outerspace Treaty, which really defines what the human presence in space can be, is very clear about what it's aiming for, which is no nukes in space, please. No super weapons, no nuclear-powered super soldiers. You can't send nuclear weapons to space. You can't drop bombs from space. You can't drop titanium rods from space. No nukes in space. And they really are pretty committed to that. But if SpaceX went to Mars, they would fall under the jurisdiction of the United States, which is a signature of the Outer Space Treaty. So they would be beholden to the laws of the Outer Space Treaty and to the United States. And there's a bunch of things in there which SpaceX probably wouldn't like, such as you have to let anybody use any of your facilities. Essentially the same rules as going to Antarctica. That if anybody shows up at your facility on Mars, they get to hang out and use your facility. So SpaceX is probably going to push for a new kind of requirement. The other thing is that fairly recently, they're in the process now, NASA and other groups are in the process of rewriting the planetary protection rules. And so it may very well be that in the next little while, they'll have much more stringent and much more modern ideas of what it means to be able to infect an alien environment and what the protection precautions are going to be. And it might very well be then that sending humans there without taking precautions is a violation of the Outer Space Treaty. So I would suspect that we're going to see something in the next couple of years that will define and make that a lot clearer. I'm sure that there will be laws figured out before SpaceX actually gets humans setting foot on Mars, on what they can do and what they can't do. But, possession is 9/10 of the law. And so if SpaceX can get to Mars and you can't stop them, then there's not a lot you can do about it, right? Same thing with asteroid mining. You may have rules about asteroid mining, but if I can just go to an asteroid and mine it and then stay out in space and you can't reach me, then what do your laws count for? So, Dustin Smith, what are your thoughts on the 100 or so super spiral galaxies that we recently discovered are spinning much faster than physics should allow? This is fairly, this has been known for a long time. This idea that spiral galaxies rotate too fast. And so I think ours is rotating at like 220 kilometers per second. Turning, and they found spiral galaxies, like the bigger they are, the more massive they are, they're actually rotating a lot faster, and they found ones that are rotating almost 3 times the speed of the Milky Way. And they should be tearing themselves apart, but they don't. And the understanding is that there is this vast halo of dark matter surrounding the galaxy, and that acts like the anchor of the entire galaxy, holding it all together. The galaxy itself is just a tiny fraction inside this bigger dark matter halo that is pulling together the entire thing. Jim Katzaman, being in the middle of Jupiter's intense radiation, how would a Europa lander keep from being fried? It wouldn't, and that might be a design preference. So if you have like a lander land on the surface of Europa, it's going to be getting intense radiation from Jupiter, and is going to fry its electronics. But the bonus of that is that it is going to potentially get sterilized. All the life on it is going to get sterilized. And so one of the ideas is that you get this rover that lands on the surface of Europa, releases some kind of temperature probe that tries to go down through the ice to reach the subsurface ocean. And the lander on the top just gets fried and sterilized. And maybe you can harden some part of the lander so that it can still communicate with Earth, even though it's being constantly bathed in radiation. So, in fact, Jupiter's radiation might be a feature, not a bug. Rigel16, what do you read in your spare time? I don't have spare time. So I play video games in my spare time. I watch movies and TV shows with my wife, hike, but I do read. I try to force myself to read to sleep as opposed to falling asleep to podcasts or YouTube videos. And so recently I've been reading, but I also have a ton of books that get sent to me. So that's typically what I read, is I try to catch up on the piles of books that come my way. I know, it's a terrible problem to have. And so my hope is, I want to do justice to all these people who are sending me their books. And so I want to be able to try and do videos that talk about some of the ideas, because sometimes you only get neat ideas. They're only in books. They're not on the web. They're not out there. These writers have gone and interviewed people and gathered this information and put it in a book. And you're not going to find it anywhere else. And so I would love to work with them to turn them into videos. But then that's not turning into spare time or for fun anymore, is it? So I don't read for fun in my spare time, mostly. But I'd like to do more of it. Chris March, has anyone found the bolts lost inside James Webb yet? I had heard that sort of they had done a test and some bolts and washers had shooken loose in the shake test, and then they pulled it all together and reassembled it, and it's not a problem. But if you know something that I don't know. 1000T Pulse. Do you think that it's possible the reason we haven't found the aliens it's because they're so different that we can't comprehend them? Well, it's almost certain that that any alien life that we find isn't going to be like us, but they still live in the universe. And so they still have energy and they still have matter. And they still have all of the same atoms that we have access to. They have the same kinds of energy that we have access to. They have stars, they have planets, they have vacuum of space. And so even if they function in ways that are very different from us, you would still expect them to use the same kinds of energy and matter. And so we would recognize that. So it's like we would see something that was maybe replicating and using up matter. Now, it's entirely possible that what we see as the universe is not what the universe really is, and that there could be some other kind of life form that is utilizing forms of energy and matter in higher dimensions that we can't even perceive. But that's also kind of like they don't exist from our perspective. So, if they have to follow the rules of physics as we understand them so far, then we would expect to see them. They would be different, but we would still expect to see them. Alexander Pita, is there any propulsion technology in the works that can make a breakthrough on space exploration? I mean, the most interesting recent breakthrough is things like the Breakthrough Starshot, which is an idea of using laser propulsion, but even that hasn't been tested. So no, I think the biggest technology development that's been made in recent time is just that SpaceX has landed rockets. Like, if there's anything that's dramatically changed everything, it is that we are now entering the era of reusable rockets, and we're not even there yet, right? SpaceX has demonstrated that they can re-land the first stage. They haven't demonstrated that they can save the second stage yet. They will with the Starship in theory. When that happens, then everything changes, because then you can get cargo to space at a fraction of the price that we do today. So that's the thing that will change everything. And then, I mean, we all want super duper ion engines and fusion drives and laser propulsion, photonic propulsion and antimatter propulsion and warp drives, but those are all still super pie in the sky. Suzu, did you see Halley's Comet? I did, but it was like 1986. I was pretty young. I don't really remember seeing it. It wasn't that great. Janelle Duncan, are there any comets due to pass the Earth in the next 20 years? There are comets that pass, but I don't know of any that are due to come super close that they guarantee that it's going to be bright. Halley's Comet, once every, whatever it is, 80 plus years, 75 years that it comes by, is one of the few really dependable bright comets, and it has an orbit that brings it fairly close to the Earth. But apart from that, the kind of crazy thing about comets is that they're random. It's a crapshoot. They come when they come, and you never know when you're going to get a chance to see one. But it's a wonderful surprise when you do see a bright comet in the sky. It's I'm sure many of you have never seen one, right? Which is kind of amazing and kind of sad. And yet they are phenomenal. And because unlike the Northern Lights, so the Northern Lights, you go out and they're random if you can see them. Comets are just there when they're happening, and you can go when you want to see them and they're happening. So comets are great, and we deserve one. Peter Bondi, during Earth's heavy bombardment period, how frequent were large impacts? Videos make it look like it was every couple of seconds. That isn't accurate, but any clue how often? No, that's not accurate. I don't know what the period was, but it was significant. But it would have been on the order of hundreds, thousands of years between bombardments, but it was still much worse than anything we have today. HX rocks. Will the 2024 moon landing actually take place, or will the whole plan be blown into the wind prematurely by the Senate or some U.S. thing? I haven't heard a change in the date yet, but I have heard, as you said, some people in Congress or the Senate starting to push for a later date, like maybe back to 2026, maybe to 2028, which is actually what NASA had originally proposed. And then for some reason, certain forces wanted to try and push that date so that it was a little bit earlier. So it may very well be that we'll get a slip back to say the 2026 or 2028, and no one will really bat an eye. But SpaceX is saying that they're going to land the Starship on the moon in 2022, right? Like if that happens, what is the point of Artemis at that? You just buy a ride on Starship and you just make the whole Artemis mission obsolete. The SLS is stopped and dismantled. There is no purpose for it anymore. So SpaceX is the thing that could throw the whole process just right out. Eric 1, do you know if there are plans for a Starship version that will be able to service satellites like when they used the shuttle to service Hubble? There's actually some mock-ups of the Starship where it's maybe one of the older versions, one was the BFR, where it's got like this, it's got a satellite launching version of it, and it's sort of like, it looks like a big, like a whale, like a humpback whale. It's sort of opening up and releasing a spaceship. And so when you think about the size of the launch fairing on Starship, it's huge. And so it could theoretically fly out, match with a satellite. Astronauts could fix the satellite from Starship, or it could gulp down the satellite and land on the Earth, and then they could do servicing to it, and then it could launch again a few days later and go back to space with it. So again, once this thing flies, if it flies, then things that used to be too expensive, too complicated, not worth doing, suddenly become reasonable and even become incredibly cost effective. So that's what we're going to wait for. So who knows? OD, what is the ratio of resources, effort spent on space vision, like space telescopes, in comparison to the search for extraterrestrial intelligence, like radio antenna and receivers? So the ratio is infinity to zero. In other words, all the money is spent on science instruments, space telescopes, radio telescopes, ground-based observatories, things like that. And zero of the money is spent on extraterrestrial, on SETI instruments. The only exception is there's a couple, like the SETI Institute was able to get their own private radio telescope, the Allen Array, thanks to Paul Allen. But apart from that, there's no money sent. In the astronomy community, even being a SETI researcher is considered not worth doing. So there's really no funding provided for SETI research at all. If you want to contribute to the SETI Institute, I'm sure they would be glad to have your donations. Adam Weaver, do you think that we'll use CRISPR to modify humans to travel in space? I don't know. I don't know whether we would get to a point where genetic modification would allow us to minimize the damage that we would do to be in microgravity. It probably will make the most sense. I mean, maybe to be more radiation tolerant, but even that, like the thing that will eventually make the most sense is to provide artificial gravity through some kind of rotating space station, and then some kind of artificial magnetosphere or enough radiation shielding so that we don't get damaged by the radiation. Or maybe you just absolutely minimize the amount of time that you spend in microgravity. Dustin Smith, when can we hope to see a collaboration with you and Joe Scott? I did a collaboration with Joe Scott. We did one a couple of years ago on the Mars rovers. Do you want another one? I'll talk to Joe. Let's see. Everyone wants to know. Jason C. asks, can humans transform Venus to be a habitable planet? We talked about that last week. In theory, Venus could be terraformed, but all you have to do is block the light from the sun hitting Venus and then scoop up and sequester away 93 times the atmospheric volume, or I guess the pressure in carbon dioxide. Good luck. It'll be hard. BK Nishim, is there any telescope that stream live? Me! I do, in theory. I mentioned this last week. Again, the new telescope has been fixed, set up, and I'm going to be getting instructions to use it in the next couple of days. So hopefully I will be live streaming again, either here on YouTube or on my Twitch channel. Drew Durant, what upcoming astronomical events are you excited about? The transit of Mercury is coming up next month. So that one, November. You won't see it again until 2032. So make sure you watch it. Mark Starkiller, I saw that they're making an experiment to make regolith good for plants, but why if hydroponics or aeroponics is much better than for most of the plants? Why not? Yeah, I mean, in theory, hydroponics and aeroponics would be the best way to grow plants. But I mean, anyone who's done any hydroponics knows that you can get diseases going through the hydroponics and that will kill all your plants. So there are lots of good reasons why you may just want to use regolith. And so they have shown that you don't need to rule out regolith as a place to grow your plants as well. And so they may find that some stuff actually works really well to grow in the regolith. Other stuff is going to be best to grow hydroponically. And so it just makes sense to try everything, every idea right now. Brandon Warren, why don't we see photons until it hits something? Shouldn't we see them streaking by the Earth as they head out into deep space? Well, the trick with a photon is that the only way to know that a photon is there is to observe it. And so back to the uncertainty principle, right? You can't know the position and velocity, you can't know where a photon is until you observe it. Until then, it can be anywhere in the universe, right? The probability function. So, but yeah, I mean, you can't see a photon until you observe it. And that's why photons can travel through the entire universe until they hit your eyeball. And then you observe them, and now they energize your body a little bit, and they're gone. And so it's kind of amazing to think about this idea that a photon traveled all the way, billions of light years, and then reached your eyeball without running into anything. Brad Saley, if we could make something in space like a pole the distance from Earth to Mars, and we had something that could push and pull this object, would this be transferring information faster than the speed of light? No. So if you had a pole and you pushed it, right, what you're doing when you are pushing it is you are essentially sending a compression wave down through that pole. So atoms in the pole are bouncing to the atoms beside it, and bouncing to the atoms beside it, and that compression wave is moving through this pole as you are pushing it, and it can't go faster than the speed of light. In fact, it goes way slower. The maximum speed that a compression wave will move through a pole, even if the pole was made of like diamond or something, is way less than the speed of light. So no, you can't do that. Let's see. Neil Yu, can they make an anti-asteroid version of Starship? Yeah, why not, right? Again, if they're cheap to fly, why not fly a Starship up to an asteroid, land on it, then start mining it for your Starship engines, and then maybe figure out a way to start thrusting from the surface of the asteroid to try and move it. So, or drop, disgorge a whole bunch of robots that will build a mass driver on the surface of the asteroid. Or maybe you just go and you just scoop up right? You land your starship on the asteroid, and then you just transfer a whole bunch of that asteroid into the starship, and then it just flies away. It takes it somewhere better. So once we've got inexpensive access to space, reusable rocketry, then things that seemed crazy suddenly become reasonable. Cody Murr, where did Thea come from? I was under the impression that multiple planets can't form in the same orbital path. How did it get into the same path and crash into Earth? Please explain. Right, so it didn't form in the same place as the Earth. It formed in another orbit. And then through gravitational interactions with other worlds in the solar system. When you think about how far Jupiter, Saturn, Neptune, Uranus, they all moved in the solar system, it actually happened very quickly, probably within tens of millions of years, maybe even faster than that. So I've even heard like a few 100,000 years to make all of that changes in the positions of all of the planets. Caused a lot of mayhem. And so if there was an extra Mars-sized planet, it could have gotten shoved into an orbit where it and Earth eventually crashed into each other. Jeff Lee, I see large stars orbiting black holes. What would happen if a giant star just hit a black hole directly without orbiting? In other words, can a giant star destroy a black hole if it hit it straight on? No. If a giant star hit a black hole, it would just be gone. Yum, yum. All gone. Now to have a direct hit on a black hole is super unlikely. So what's more likely is the star comes in super close. As it gets within the Roche limit, it gets torn apart. It gets turned into an accretion disk around the black hole, and then it all goes in. But no, if you hit directly, and like say you've got a supermassive black hole and a star hits directly, it's just gone. Added to the mass of the black hole. Glenton Campbell, what if we set up factories on Mars? Could that terraform it? The problem with Mars is that, define terraform, like make it Earth-like. The problem is that the solar wind from the sun is constantly blowing at Mars, and it is knocking the atmosphere off of Mars and out into space. And so if you make an atmosphere, the sun is just going to blow your nice atmosphere away into space. You need to block the solar wind. If you block the solar wind, then you can thicken the atmosphere, but you still don't have a magnetosphere that will protect people on the surface of Mars from the radiation of space. And there's probably not enough material on Mars to be able to thicken the atmosphere to the point that you could breathe and take off your coat and walk around. So we may get to a point after hundreds, thousands of years where Mars sucks less, but we'll probably never get to a place where Mars will be a nice place to live. It's all you get is sucks less. So enjoy Earth, because Earth is the best. Pup 314, is it possible that the sun is gravitationally in orbit of the Alpha Centauri system? No, the sun is not in a gravitational connection with Alpha Centauri. Alpha Centauri is drifting away from us, happens to be the closest star system to us today, but tens of thousands of years into the future, it won't be again. And other stars will be close to us. So we're all just kind of jostling around as we go around the Milky Way. Jameson 1776, the X-37B just landed after 780 days. Any thoughts on what it's doing? I've read that it launched satellites without giving notice, possibly violating international law. Nobody knows. There are people who know what the X-37 does. My guess, this is only my guess, is that the purpose of the X-37, because the purpose of the X-37, I think, is to test materials in space. And the reason I think that is because why else would you need it to come back to Earth? So you want to be able to have something go to space, open up the pod bay doors, and then expose various kinds of, Vanta black to space itself and different kinds of electronics and all that kind of stuff to find out how well these things handle being in space for 780 days. And then it shuts the pod bay doors and lands again. But that's just my guess. The only rational reason I can think of to send a space plane to orbit, have it orbit around, other experiments maybe, but I just imagine new materials, computers, composites, things that you're going to try and figure out what can handle being in space. Let's see. Long ride music. Do you think another Voyager mission could happen in the near future with the tech now if we could somehow pass Voyager and get faster? The thing with Voyager is they were the flybys, right? The Voyagers were really our first big dramatic go at flying past the 4 big planets in the solar system. So the pioneers went ahead of the Voyagers, but the Voyagers had much better instruments on board. Now that the big flybys are done, there's no point of sending another Voyager. Now you send the orbiters. And so we had an orbiter at Jupiter with Galileo, and now we have Juno. We've had an orbiter at Saturn with Cassini. It's time for an orbiter at Uranus. It's time for an orbiter at Neptune. There's no need for a Voyager anymore. Mike McHugh, if the universe is infinite, are there an infinite number of Earths? In theory, yes. That in an infinite universe, anything that is possible, such as the Earth, will happen an infinite number of times. Stevie, Fraser, what in your opinion is the most realistic space movie? What is your favorite movie? I think the most real, I really like The Martian, I would say. There's a couple of things where they weren't super realistic, but for most of it, it was very realistic. I'm a huge fan of The Expanse. I mean, apart from a magic fusion drive, the rest of the show is highly realistic. They really deal with gravity and acceleration and changes in forces really well. It's a real pleasure to see a show that takes scientific accuracy very seriously. And they came up with ideas in the show that you just wouldn't see in other shows. And they were a result of their scientific accuracy. And the example I have is just, in an episode, I don't want to spoil too much, but they're in a spaceship that's flying and it has to change its directions very quickly. And a toolbox gets opened up. And so now you got these tools floating around inside the spacecraft and they are changing directions. And the tools are flying around every time they change direction and they're lethal. And I've never seen that before. And yet it seems reasonable. So The Expanse. I got about 2 minutes left and then we're going to wrap it up. So I'm sort of skimming through here. I tried to get through as many questions as I could today. So I'm really hustling. WIS, when will we start living off fusion energy? Who knows? I mean, the joke is, of course, that we are 30 years away from fusion energy. But realistically, the ITER experiment in Europe is going to attempt to do positive power fusion within the next decade or so. And so I think what we're going to see is some experiments, whether they're in ITER or in China, successfully demonstrate that it is possible to produce more energy with fusion than goes into it. And then 20 years after that, they're going to have commercialized power plants. So I think it feels like we're 30 years away from getting power from fusion. Gary Swift, are you planning anything soon with Isaac Arthur or John Michael Gaudier? No, I'm not. And not because I don't like them, or it's that we have nothing in the works. John Michael Gaudier and I did a couple of collaborations in the last little while. And Isaac and I have done a bunch. So it's just, one of the things that I'm really trying to do is try to feature as many newer creators, people who don't have any followings yet. So, if you know of creators who don't have a lot of people watching their stuff yet, but they're good, please let me know so that I can tell everybody about them, because that's my real goal. But, if an idea comes up, Scott Manley and I have been trying to organize something, so we'll get there. Let me see. Man, there's so many questions today. Tom Tom C., what do I think SpaceX's plan is to make it through the Van Allen belts? The same thing as NASA, to go quickly, to follow a trajectory that mostly avoids the bulk of the Van Allen belts and minimize the amount of radiation. Horizon Brave, did it launch under its own propulsion? How did no one see it being launched? Are you talking about the X-37? No, it launched on top of a rocket and everybody saw it launch. And everybody tracked it as it moved in space. It even changed orbit once at least, and people were able to catch that change of orbit. So, let's see. I think I've reached 6 o'clock, so I think it's time to wrap things up. So thank you, everyone, for watching. Thanks for the people who donated. I really appreciate that. It means a lot to me. And thanks to the moderators. I know we were rolling fast today, but hopefully I was able to get through as many of your questions as I could do. I don't know what the number was there, but it felt like it was a lot of questions. So I didn't spend a lot of time. I tried to get through as many of them as I could. So like I said, new episode dropping probably tomorrow, maybe the next day, a new question show this week, and another episode later on in the week. So stay tuned. Lots of good stuff coming. All right. Thanks, everyone. We'll see you all next week. Now the uncomfortable stop.